Alright, in this particular video, we're just going to do a quick little introduction. You'll see this, this chart when you guys are working with all of your rational function assignments. We're going to be talking about vertical asymptotes, horizontal asymptotes, what those are, and just show you kind of some pictures just to lead up with, okay? So here's different examples of 3 different types of situations you could run into. This is an example of a situation of a rational function that has no horizontal asymptote. It actually has a slant asymptote, which we'll get into in a little bit. It does have a vertical asymptote. So the vertical asymptote is at -1 because -1 plus 1 is 0, and anytime you make the denominator equal to 0, that's going to create what's called a vertical asymptote. You can clearly see it right there. So we have a vertical asymptote right here. Over here, we have a horizontal asymptote and a couple of vertical asymptotes. So if you're wondering why the vertical asymptotes are at -1 and +1, I'm going to go ahead and factor this real quick because they don't have it factored. So let me go ahead and get that factored. So you'll see this x squared minus 1. Well, that factors to x plus 1 and x minus 1. That's a difference of squares. X plus 1 and x minus 1. And so -1 makes it equal to 0, and +1 makes it equal to 0. So that's why you have these 2 vertical asymptotes that you can see right here. So I'm going to go ahead and draw them in. So we have a vertical asymptote right here, we have a vertical asymptote right here, and we also have a horizontal asymptote right here at y equals 0, right there. And the reason we have a horizontal asymptote, which basically is just a boundary in the graph, is because this power is greater than the power that we have over here, and even though you can't see it, that's actually 3x to the power of 0. Alright, so this power is 2, this power is 0, because you just have a constant. And so that's one of the rules for horizontal asymptotes. Okay, and then we have one more. We have a situation where we have a vertical asymptote at 3. Alright, but we also have a horizontal asymptote at 2 because it follows the third rule. You'll notice right here, this power is 1, and this power is 1, and whenever you have the same power, then whatever the coefficients in front of those powers right there, you just do 2 divided by 1. There's the 2 divided by 1, and that gives you your horizontal asymptote. That's why the horizontal asymptote's at a 2. So the horizontal asymptote is this one right here at a 2, and the vertical asymptote is right there at a 3, because 3 minus 3 is 0. So those are the 3 rules for horizontal asymptotes. The 3 rules are this, okay? If the degree of a of x, which is whatever is in the numerator, is greater than the degree of b of x, which is in the denominator, okay, then you're going to have this situation right here, no horizontal asymptote, okay? But if the degree of a of x is less than the degree of b of x, then you're going to have the situation we just had, which this is the situation where it's at y equals 0. And then the last situation is if the leading coefficient, if the degrees are equal, okay, which was our last one, that was this one right here. If the degrees are equal, then it's the leading coefficient divided by the leading coefficient. So 2 divided by 1 is 2. So those are the 3 situations for horizontal asymptotes. A of x being whatever's in the numerator, b of x being whatever's in the denominator. But if we go down a little bit further and we talk about oblique or horizontal asymptotes, okay, this is when you have 1 degree higher. All right, when something's 1 degree higher, you get what's called an oblique or a slant asymptote. So I'm going to show you kind of how that's taken care of. So if we take x to the power of 4 plus 3x cubed, and we do a little long division, all right, and we go x cubed minus 1, and we go into, and we kind of divide this into this, we're going to get an x, and x times x cubed is x to the power of 4, and x times 1 is a minus x. And then when we subtract this, we're doing a little long division here, these cancel out. This just drops down, and you have 3x cubed. And then you have a negative times a negative, which is a positive x. So then you have to ask yourself, how many times does x cubed go into 3x cubed? And that answer is plus 3, because 3 times x cubed is 3x cubed, and 3 times negative 1 is negative 3. And when you subtract that one more time, you end up getting x, and then a negative times a negative is a positive. You get x plus 3. So basically, it goes into it x plus 3 times. This is the remainder, but we don't worry about the remainder. We just worry about this part right here. And that's why it says it has an oblique asymptote at x plus 3, which is this dotted line right there. That's your x plus 3. But it also has a vertical asymptote at basically at x equals 1. Now, why is it at x equals 1 right there? Because if you plug in a 1, 1 times 1 times 1 is 1, and 1 minus 1 is 0. So you have a vertical asymptote and you have a slant asymptote. But slant asymptotes only happen if it's 1 degree higher, okay? So if that's a 4, that's got to be a 3. If that's a 5, that's got to be a 4, and a 6 and a 5, and so on and so forth. So that's the rule for oblique. Now we have what's called point discontinuity, also known as a removable discontinuity. And so how do you know if you have point or removable discontinuity? You'll notice you see these factors right here. These cancel out. So whenever you cancel out a common factor, you have what's called a point of discontinuity right here. So we have a point of discontinuity at x equals negative 1, and that's what's known as removable discontinuity. All right, so what do you need to look for? Look for common factors, and if they cancel out, you know you have a point of discontinuity at whatever number makes that equal to 0, which happens to be a negative 1. Okay, so those are the rules you're going to be looking for as you go through these assignments. Just make sure you understand the difference between slant asymptotes, points of discontinuity, and your rules for horizontal asymptotes. And these are the 3 rules for horizontal asymptotes that I'll be going over in each of the lessons. Okay, so hope you guys have a good day, and I will finish right here. I'm going to zoom out a little bit real quick, so if you need to pause and take a look at these notes and write them down, you can zoom in and take a look at them right here. So there's the notes for vertical asymptotes. You could pause the video and write them down. Here's the rules for oblique asymptotes. I'll zoom in a little bit more so you can write those down. You can pause the video if you want to. And then we have the rules for points of discontinuity, so you could write those rules down in your journal as well. You'll have a good day.